Topic 3, estimation, 3.1 rounding. So we can round to a number to a certain degree of significant figures or decimal places. We'll have looked at rounding to the nearest whole number. So if we've got something like 4.7, we should know that will round to 5. If we've got 44, we could round to the nearest 10, and that would approximately be 40, and so on. And we know the basic method of rounding is essentially we identify the position of the last digit and we put a dashed line or a dotted line after it. We look at the next number and we decide if it's a 5 or more, it gets rounded up, otherwise it gets rounded down. So in 4.7, we'd put our dashed line in between the 4 and the 7. 7's bigger than 5, so that means we'll round up. So that's why we went to a 5. Similarly with 44, the 4 is less than 5, so that's mean we'll round down. So 44 gets rounded down to 40. Significant figures, this is new to us. And the first significant figure of a number is the first non-zero digit. So in the number 4.7, the first significant figure is 4. In 44, it's also 4. In 310, the first significant figure would be 3. The second, third, and fourth significant figures are just the digits immediately after that, regardless of whether they are numbers or zeros. So in 310, that's the first significant figure, the 1 is the second, and the 0 is the third. In 44, the first is the 4, and the second is also 4. And in 4.7, the second significant figure was a 7. In this example, we've got 125.17. So the first significant figure is the 1, the second is the 2, the 5 is the third, 1 is the fourth, and 7 is the fifth significant figure. With numbers less than 1, so 0.00 or whatever, all those decimal numbers, we don't count the first zeros as significant. So in 0.034105, the 3 is the first significant figure because it's still the first non-zero number. The 4 is the second. 1 is the third. Now this is a 0, but it occurs in the middle of the number, so it is significant. So it is the fourth significant figure, and then the fifth significant figure is a 5. Example 1. Write 24,671 to two significant figures. So the first significant figure is the 2, the second is the 4, so we're going to put our dashed line after the 4. We look at the next number is a 6. 6 is more than 5, so that means we're going to round up. So the 24 is to turn into a 25. But we have a bit of an issue there because our initial number was 24,671. And it would make sense to say that 25 approximates to 24,671. So we need to make sure that the place value stays the same, so we have to add in these 3 zeros. So you might think, well, does that not 5 significant figures because there's 5 figures there? Not really, no. So the issue is that the 2 in the original number is the place value is a 10 of 1,000. So that's the same in your rounded value. So these 3 zeros are necessary to retain the place value. If they weren't there, 25 does not make a good approximation for 24,671. So we need those 3 zeros. Second example, 24,671 to 3 significant figures. So we'll look between the third significant figure and the fourth. So we've got 1, 2, 3. So we're going to be looking after the 6. Again, it's a 7, so that means we'll round up. And that will turn the 6 into a 7. So we've 24,700. And again, we need to add in the 2 extra zeros to make sure that the place value is retained. Otherwise, we'd be saying that 247 is approximately the same as 24,671, which is completely daft. The third example, So it's 124,541 to three significant figures. So the 1 is the first, the 2 is the second, the 4 is the third significant figure. We look between the 4 and the 5. 5 means we round up. So the 124 is going to turn into 125. But again, the original number was 124,541. So we need to put 3 extra zeros to retain the place value. And finally, then example 4. We've got 124,571 to 4 significant figures. So 1 is the first, 2 is the second significant figure, 4 is the third, and 5 is the fourth. We put our line after the 5. 4 means we'll round down. So the number's going to be 124,500. So again, we need the 2 zeros to make sure that the 1 stays as 100,000. And 124,541 has been rounded down to 124,500. Example 5. Write 0.003451 to 2 significant figures. So the first significant figure is the first non-zero number. So the first 3 zeros are not significant. So 3 it's the first, 4 is the second. So we'll put our line after the 4. We've got a 5, that means we'll round up. So our number that we'll round is 0.0035. Now you might say, well, let's add in 2 more zeros so that we have the same number of decimal places as were in the question. However, these extra 2 zeros that we have at the end, they do not make any difference to the place value of the 3 and the 5. Previously we added in the zeros to make sure that the place value was retained, but this is in the thousandths column, as is the 3 in the original number. The 4 was in the tens of thousandths column, as is this 5. So we don't need those zeros anymore, so we're just going to get rid of those. So it's 0.0035. In example 6, we've got 0.003451 to 3 significant figures. The 3 is the first, the 4 is the second, the 5 is the third, because remember, these zeros are not significant. We look between the 5 and the 1. We've got a 1 that's less than 5, so we're going to round down. So we're going to get 0.00345. Again, we don't put another 0 in because that's not going to change the place value. It doesn't do anything to the number. The only thing it does, it actually makes it more significant. So we leave it as 0.00345. The next example, example 7, write 0.009995 to 1 significant figure. So the first 3 zeros don't count in terms of significance. So the 9 is the first, and the second 9 is the second significant figure. That means we're going to round up. So the 9 is going to round up to a 10 really. So we've got 0.010. Again, you might be thinking we need the 0 because the 9 is in the third decimal place value, as is this 0. However, this 0 is not needed because that looks as if it's 2 significant figures. The 0 is not changing the 1's value, so it's just going to be 0.01. So we've only 1 significant figure showing in our answer. In example 8, we're looking to 3 significant figures. The first 9 is the first, the second 9 is the second, and the third is the third significant figure. We're going to look at the 5. That means we round up. And that's going to round the 999 up to 1,000 really. Or well, not 1,000, but it'll look like 1,000. So it's 0.0100. Now, this is an exception to it. But because we've been asked to show to 3 significant figures, so we need these extra 2 zeros so that we have 3 significant figures. So remember, we said that we normally don't need to add in the zeros because it's not changing the value. So these 2 zeros aren't changing the value of the 1, it's still 0.01, it's still 1/100th. But if we didn't put those last 2 zeros in, it would only be to 1 significant figure, as was the answer in example 7. So we need to put these 2 zeros in to make sure that our answer is to 3 significant figures.